So now that we figured out how to get our way through the graphs of each of those equations, we want to talk about solving them algebraically because usually that's more convenient. However, because they're square root problems, we have to be careful, and here's why. So obviously, if you write -1 equals 1, that's not true. However, if you square both sides, so that means -1 squared and 1 squared, you're going to get 1 equals 1, and that is true. So when you square both sides to solve a problem, you have to be really careful. Squaring is an irreversible step because there's two values that can produce the same result. So if you just square root to undo the square, there's two different answers to that. There's 1 or -1. It doesn't take you back to the original number. So you have to be really careful about that. So what we learn is we need to look out for what's called extraneous solutions. So if you think about the word, what extra means, it means outside of or in addition to. So when you hear the term extraneous solutions, you just think, oh, those are solutions that are outside of the actual solution set. So in other words, they're false solutions. They're not real because of this whole squaring issue. Now, if you're cubing or raising something to a 5th power, a 7th power, any odd power, you don't have to worry about that happening. You won't have any extraneous solutions because basically there's exactly one value for any cubic or odd root. So you can do the cubic root of -27. There's only one answer. The cubed root of +27. That's only one answer. So you're off the hook for those. You don't have to worry about making these false solutions appear. So it's just really the even power or the even index roots you have to watch out for. So really, there's only 3 basic steps to solving pretty much any radical equation. Step 1 is you want to isolate your radical, and that we've kind of already done that before. Then you want to undo whatever type of root you are. So I'll just say the nth root for now, and opposite of taking something with an nth root is raising it to the nth power. So for example, if it's a cubed root, you're going to cube both sides. If it's a 4th root, you're going to raise it to the 4th power. If your index was even, you're going to check for your extraneous solutions by plugging your solutions back into the original problem. And once we do a couple of these, that'll start to make sense. So I'm going to do a couple here. We have 2 times the root of x plus 1 equals 4. So the first thing we need to realize is 2 is not in the radicand. So 2 needs to leave. So this is my new problem. Now, obviously, to undo a square root, you are going to square both sides. You just need to realize, hey, that can create some not so good things because of that whole -1 equals 1 thing. So we'll just have to check our answer at the end. So if I subtract 1 on both sides, I get 3. Now I would have to put 3 back in for x. So it's not an optional move. You have to check this to see if it works because sometimes it won't. 3 plus 1 gets you 4. The square root of 4 is 2, and 2 times 2 is 4. So that works.